Okay, so one point here is that if anyone's invested in coal right now, maybe you should sell that stock.
Yeah. Yeah, I'll tell you why.
Yeah, he'll tell you why. Yeah, prices are going down and stuff. I don't know. I was driving along Bethel Road and pull along the CSX tracks right up north. I guess it probably went up to the port and probably out to China. I guess I don't know. Is there a coal-fired power plant that far north in Ohio?
There's only a few left that are still operating.
I just think they're all Southville.
Yeah, they're most of them.
There are a couple of them. And
Those
those
are
are
Ohio.
yeah.
That's good, man. Sold.
Right after.
Yeah. We're still gonna run it. I'm not clear what's gonna happen to it. It's a pretty cheap coal plant, so that's part of the reason it's still running.
That's my favorite one is when he starts talking about the Gavin plant. You know, that's when he's always been fun to AP about. Famous blue cloud.
Yes. Yes.
You guys always trying to get that out, famous blue cloud. Okay, well, whatever, it's your turn.
All right. So, first of all, hopefully everyone had a chance to watch the video, which is on part one of coal. I know a couple of you have emailed saying their troubles.
Oh, yeah, sorry about that. I did put a YouTube up there. Hopefully that helps. Having trouble.
Yeah.
I don't know.
If not, let me just, I'll just do a quick 2-minute synopsis of what part one was about, because it really is the background on coal, including pointing out some of the pictures here. Just the red one, yeah, there we go. So you got a picture of a coal-fired power plant. One unit's operating, that's smoke coming out from that operating unit. The other unit is not operating. That's the cooling tower, right? So that's a typical layout of a coal plant. You can see some of these conveyors as they move the coal into the power plant itself, which is down here. Then you got a couple of different mining operations, types of mines. These are both from underground mines, and they're pictures of what's called a continuous miner, which is a big mining change that occurred in the 60s, really, and kept getting improved. And what it really effectively meant was the days of, the old movie, you see an old movie, some of the coal mines are actually picking a shovel and all that stuff. That ended pretty much with continuous miner. Then it was people going underground, but they were driving machines. They were basically mining coal. And then this is a more recent being in the 80s. They developed something called longwall technology, which was even more efficient way of doing underground mining. I won't get into details on that. So we talked a little bit about that on the video, and also
Once.
I do. Which one, the bottom one or the side one?
You just have to answer for you.
Okay. So we talked about what is coal. Yeah, go ahead. Yeah. And so you could see coal is the most carbon intense fossil fuel, 75% on average. Some types of coal, we talked about crazy coal, are more carbon content. That's about the average. And there's a lot of there's hydrogen, of course, which is why it's called a hydrocarbon. There's nitrogen, which burns as well. And then you have things like ash, which is typically about 10%. That's stuff that doesn't burn, it's inorganics. Okay. And then this movie talked a little bit about
Phil, we gotta have the advanced. Is that a PDF or?
PowerPoint. Maybe if I hit the one down at the bottom, is that supposed to work?
That's the right one.
Okay.
So what? No.
Okay, well, I can advance it. That's all right. Just do this. I got it.
Is that all right?
So we talked about the different classifications of coal. And again, I won't belabor all this. The point there is that much of the difference in the coal types has to do with how much energy content they have. And the coals that are the highest energy anthracite, not very much of it. Some of the earliest coal that was ever used in the early 1900s was anthracite. And it was also used a lot for, believe it or not, residential coal and heating. Today, very little anthracite's burned because there just isn't that much of it. A lot more bituminous and subbituminous. Those are the two main categories. And bituminous has higher energy content, so it's a little more valuable. And then a bit about coal usage. 80 to 90% is used for electricity. And if you really look at it, domestic coal consumption, it's really about 90%. Part of the reason for that is 10% is sort of exported. And here's the coal consumption figures. And of course, as we'll talk a bit more about today, we've seen this very significant decline in so there's a very significant decline. It started around 2005, 2007 time period, where coal consumption went from 1.1 million tons in the US down to about 700,000 tons. This is in 2018. It's now around 500,000 tons. So, excuse me, 500 million tons. 500 million tons in 2020. So it has dropped quite a bit. And almost all of that is because of electricity use has dropped off. And what else did we talk about in here? That's right. You can see the impact on the electric sector. Big significant decline. Some in the other sectors, industrial being the big one, commercial kind of staying small as it has been historically, but the electric is where the real action was in terms of changes in coal consumption. And then you can this graph's kind of neat because it goes all the way out to 2018, so we don't have till 2020, but the same pattern would exist where you notice coal is going down and gas is going up. Literally, gas is replacing coal. And that's exactly what's happening in the market. And we'll talk about some reasons for that. And then here's some of the coal qualities, a little more details. I won't belabor those. We talked about the types of specs and where coal is produced. You've got Eastern coal, really in Appalachia, which is defined broadly as everywhere from sort of northern Pennsylvania all the way down into Tennessee and even a little bit in Alabama, although very little production in that area of the country, most of it ending up being in Appalachia, at least in West Virginia, and some in Kentucky. And then you've got the Midwest. Illinois is the big coal producing area there. And then out west, the Powder River Basin is a big area there. In fact, that's the area where it's the cheapest to mine coal, has the best productivity, meaning the fewest man hours to produce a ton of coal. Why? Well, it's all surface mines and it involves using very, very, very big trucks and machines. Just imagine the biggest truck you could possibly imagine, and that's carrying the coal, and the machines are the biggest cutting machines you could imagine. And that's just sort of all economies of scale. It's developed over time, and we'll talk a bit more about that this time. And then some pictures, surface mining. One point here, just to emphasize from the video, the big point here is that coal is really a variable cost business. That the real cost of coal, most coal has already been developed. Most mines, most areas of the country that have coal, that have good coal, have already developed. Powder River Basin is a good example of that. So the incremental cost of producing coal is not really that capital oriented. It's much more variable cost oriented. It simply means, okay, I got to put more machines in to cut more rock and haul more rock and treat the coal. And so what happens in that kind of market is that it's very price sensitive, which means that coal doesn't go through boom bust cycles like we'll talk about natural gas, which does have some of those features, or oil, which has some of those features. So coal, literally, if prices start to go up, then supply comes on and tends to push it down. And vice versa, prices start to go down and people stop cutting as much rock and prices go back up again. So you can see prices tend to stay in a much more narrow band. Now, there's exceptions to that, and one of them I'm talking about in my commodity futures and options class right now is that the post-COVID energy markets, particularly oil and natural gas, but even coal now, have been going ballistic. They've been going. Why? Well, because the whole COVID and all the shutdowns and all the different things that happened to companies really disrupted supply chains, really disrupted how you produce energy. And in some cases, people just said, I don't know how long this is going to go on. No one really knew at the time, right? You know, we still don't know in a way because we're all wearing masks still, right? So, you know, how long is this going to last, right? And that impacts demand. So a lot of oil and gas producers, seeing prices had dropped, where they might have said, oh, this is real temporary, so we'll hang on and keep producing. They cut back production a lot. And coal did the same thing. And now all of a sudden, demand is pretty close to 2019 levels. It's kind of mostly come back. And with that, well, the supply isn't there. So we're starting to see spike in prices, even in coal, which is more unusual. Okay. One of these days I'll remember. Okay, and we went through the schematics and byproducts. So now we're on part 2 for this class. And what this is going to focus on really is more the production side, give you a sense of how that works. And then why we've seen this big decline in coal. I want to talk a little bit about all the coal plant retirements that have occurred. Why are they occurring now? What's driving those? And ends up being very, very important implications in the US energy markets in general. Okay, so here's a little background on productivity. This is an old chart, unfortunately. It's one of the better ones I could find, but as you can see, this graph only goes out to 2002. These charts only go out to 2012. But the big point here I want you to take away from this is this number is the average number of short tons of coal that are produced per hour of labor. Okay, and back in 1985, if I pull this back to 1970, it would have been about half of this number. Then like only 1 ton or 1.5 tons. Went to 2.74, then 3.83, and by 2000 it was 7 tons per labor hour. Okay, well, obviously that wasn't because all of a sudden, you know, individuals were getting, you know, stronger and lifting more coal, right? As I pointed out, a lot of it was because during the 70s, really, there was the end of miners actually using pick and shovel. Pick and shovel just died in the US. By the way, it didn't die in other countries. Other countries kept using laborers because they didn't get the machinery in as fast. But even most parts of the world now use the continuous miners I was talking about, or longwell mining, or some of the trucks and advanced technologies for surface mining. So you can see this trend. And then you also see some pretty extraordinary other factors, which is, okay, Northern West Virginia, Western, all these are, you know, almost doubling. In some cases, almost tripling. And that's kind of fits with the US total. The other thing that's going on is during this period, again, starting in the 70s, the amount of production from Wyoming, particularly the Powder River Basin of Wyoming, grew really, really fast. And that drove the average productivity in the US up higher, right? Because these are all surface mines. And they were all really big surface mines. They had lots of coal production. In fact, we'll show some visuals of how few mines actually are used in Wyoming to produce almost all of the coal that comes out of that area. And so this was really the driver in the productivity improvements. So there's good news and bad news. Well, when you improve productivity, one of the things it means is that the product, getting it to market, is cheaper. The prices are cheaper for coal. The bad news is if you're employed in mining, you can see, this is just looking at one region, which is this one here, southern West Virginia. And you can see during this period, this is even before this, the coal produced is not going up that much. It's coming up some during the 90s, 80s, 90s. But the mining jobs are going down very, very fast. Okay, so that's, yeah.
Is there a reason that Illinois is only one that's risen in 2000 to 2012?
Yeah, there are a few that sort of flattened out. And in this data, my guess is most of coal mining productivity in a lot of these areas started to get worse. And it's kind of where you put this point. This 2000 and 2002 is kind of where it started to not be as good. Some of that had to do with the fact that a lot of the innovations had occurred in the 70s, the 80s, and the 90s, and then you were there were no more major innovations. Certainly you couldn't, the trucks they already had, and loaders and all the different equipment was about as big as they could make them. So that was part of it. But why Illinois specifically? Honestly, I don't know why that trend is, but all I will say is all of these show kind of a slowing of productivity. And Illinois is a little bit aberrant. It's only one that improves, but it's not really improving by a lot. Right.
That's fascinating. I had noticed that before. A quick point though, Bruce, that so one question would be is why can or how can West Virginia, Illinois, and all these other places compete with Wyoming? And if you go back to your picture earlier that showed the types of coal that they have, one of the issues with Wyoming coal is it has less energy per pound, right, than the eastern stuff. So,
and we'll get into that very question.
Okay,
because
just
why
those numbers are Wyoming,
Because-
it's extraordinary.
Right.
large.
right, Wyoming is got very cheap coal to mine. The only problem is most of the power plants that burn coal aren't all that close to Wyoming. Right? There are some out west, but most of them are most of that coal's ending up going into the Midwest. And that means you gotta take it by rail, maybe 1,000 miles, which, starts to add up in terms of transportation costs. So that's probably the biggest reason. There's also a reason of the fact that the power plants themselves were originally designed, simply the ones in the Midwest or in the east, further east, to burn Midwest or Eastern coal. And that tended to be bituminous coal. And it was hard to burn subbituminous coal with some of those boilers. So that created some resistance. People figure out a way to do that over time, but that kept some of the Western coal from not penetrating those markets as rapidly. But nonetheless, Powder River's continuing to grow in terms of production, more than pretty much any other region. And this is just a more current thing on coal mining labor productivity. Sort of makes the point I was making that productivity has kind of reached a peak in this 2004 period, and then kind of sunk a little bit. Really, what again I would take away from this is that they kind of reached the end of productivity improvements. There's also some other factors going on. Some of the, the air pollution regulations for power plants forced the use of lower sulfur coals. And some of those regions, the lower sulfur coals, were inherently at thinner seamed mines. And that meant it took more labor hours to produce that coal. So that meant they were less productive. So you could literally have, as you did in Appalachia, a point where it sort of reached, then started to go to more lower sulfur reserves, and the productivity started to drop. So there are other reasons for it, but that's kind of the main thing. But again, the big takeaway is historically, up until sort of the early 2000s, we saw consistent gains in productivity and enormous gains in productivity. All right, well, now here we've got the longer term history of coal production, which kind of, of course, mirrors coal consumption in the electric sector, right? This coal consumption in the electric sector is about 90% of the coal produced. And you can see production kind of peaked in 2008, and consumption actually peaked in 2007, and then it's really tumbled since then. This is out to 2019, and you've seen a drop from almost 1.2 billion tons down to about 0.7 billion tons. So close to a 50% drop in production in a fairly short period of time. We're talking basically 10 years. And then you see what happened in 2020. So this is kind of updating that same chart, but now we're looking at going out to 2020. Of course, we all know what happened in 2020, right? Demand for electricity actually fell. And to show you how unusual that is, I think the last time it actually fell was like 2002, during the recession, 2001, 2002. So it almost never falls, and it fell. Overall electricity demand fell a fair amount, and coal was in a position where when it fell, natural gas prices were still low. And as I'll show you a little later, coal and gas compete for load in the electric market. And if gas prices fall, that means those gas-fired plants will be cheaper to run. They'll be dispatched ahead of more coal plants. And so that's exactly what happened. So not only did it fall a lot, it also lost more market share. So you had this literally, around 700 million tons, a little bit higher, had a little up here in 2019, and then drop all the way down to about almost as low as 500 million ton rate. So if we mirror this in terms of what has happened in terms of employment in coal mining, you go back to 2000, let's say 2008 or so, kind of peaked around 90,000 people who were employed, full-time equivalent employees, lots of shifts and part-time in that business. And then, all the way to 2018, it dropped to 55,000. That's in the US total. Now, I could actually, if I had extended this back to when I started working in energy consulting all the way back in 1980, there were about 300,000 people working in the coal industry, full-time equivalents. I'll give you an idea how much has changed. And again, two reasons, right? Well, one is these are absolute numbers. This isn't productivity number. This is the number of people who are actually working full-time equivalent. So the less you produce, right, which you know that the trend is down here, the less you produce, the more, or excuse me, the less number of people that are employed. And also you notice a big shift, right? Look at this. What gets really hit here? Appalachian coal, right? That's the area where there was a lot of shifting away from that coal, and people were moving further, more and more to Western coals. So even though the productivity was still improving in some of these areas over some of these time periods, and the chart after 2012 actually shows some, kind of pickups and improvements, even though this first decade of the 2000s was really, so we saw a decline in productivity. But even so, like the Western jobs stayed about the same, but that was an enormous amount of production. Yeah.
How does this chart look now? Have they continued to like slightly go up or?
I think it's going up a little bit because I had to, add folks, particularly in today in 2021, we see kicks back up. But this is actually going down between this year, 2018 and 2020. So it's even less. They continue to cut back production, COVID, cut back in some areas, particularly things like Appalachia, where it was more. Yeah.
So is there like a specific reason why that there was such a big drop? Is it only because there was a higher demand for Western interior coal and less for Appalachia, or was there like maybe governmental policies that also impacted?
Yes, it's some of both. And the air pollution regulations made a big difference over the course of the last 20 years or so. You had a program that started up in the mid 2012 period. And it actually got implemented around 2015, 2016. And that program is called the MATS rule, Mercury and Air Toxics rule. What that rule required is all plants that had to meet kind of a air toxic standard, which was primarily for mercury, but also for fine particulates related to sulfur dioxide. And the fine particle standard part of that ended up really driving the amount of coal that could be used from Appalachia. The only way you could really use coal from Appalachia is the plant had to have a scrubber, an SO2 scrubber, which are expensive. And some of these existing units didn't have those scrubbers. Majority, by the time we were in 2010, the majority of plants had a scrubber, but there was a big population that didn't. And those that were in the east that could really only burn Appalachian coal cost effectively had a problem because they would have to have put in a scrubber in order to comply. And a lot of these plants were very old, and a lot of those owners, AEP being one of them, decided to make any sense, let's just get rid of these plants. There were other factors too. Of course, people are looking down the road. AEP certainly wasn't saying, CO2 is going to be a reality of some kind of regulation or policy. So we'll just retire those plants. So there goes your demand for a lot of Appalachian coal. So that was probably the biggest driver in terms of policy, was those air pollution rules, the newer ones. Prior to that, you had rules that actually encouraged in the East Appalachian coal that was lower sulfur, but it wasn't low enough sulfur for the air toxics rules. And that's the way to best explain it.
So would you also say though that it was partly the air quality that drove companies towards natural gas probably?
Yeah.
But would also be just lower natural gas prices due to the fracking? As well?
Yes. Yeah, I mean, you also had this period where coal in general was going down, really after it peaked in 2008. And it's no accident that when you started to first see natural gas coming into play, particularly from fracking and therefore pretty low cost natural gas, you saw prices start to go down for natural gas. And much of this period, probably in the 2010s, if you will, the teens, that's when a lot of coal also was retired at the same time. And that made the decision easier for a lot of coal plant operators. They said, you know, this is not a hard decision. Some people actually directly replace the coal that they used in the power plants with natural gas. The thing about that, though, as we'll talk more about in the natural gas lecture, and we'll talk a little bit on the electricity side, is the best technology for burning gas efficiently is that combined cycle technology I talked about. And that has a nice efficiency. If you just burn gas, you just put in burners and burn it directly in a coal plant, efficiency is not so great. So instead of a 7,000 heat rate, you have more like an 11,000 heat rate. And that makes a big difference. It's a lot of fuel. So a lot of companies found that it was better to actually shut the whole plant down and build a combined cycle plant, or maybe buy the capacity from some merchant developer who was building a gas plant for them. So, but yeah, it was a combination of reasons that really drove this. But it's clear that the employment side was very affected mostly by the reduction in production overall. Yeah.
Just follow on that. So with one, I had thought of one thing you said, the air pollution stuff would have been known, right? So that AP knew this was coming along. They knew, I mean, these air pollution rules all came from the 1990 Clean Air Act thing, right? And then took a while for all that to get.
It's actually different because the Clean Air Act rules and the 90 amendments, they've been around a long time. And those really affected production all the way through the early 2000s. Then you had the MATS rule, not the MATS rule, what was called the CAPI rule at that time, which was a clean air power plant kind of rule, which was to reduce the SO2 requirement by another factor of 2. What was interesting was a lot of companies planned around that and started to cut back even more. Some drove some retirements, but mostly it just meant, you know, you better either have a scrubber or use very low sulfur coal. But when you got to the MATS rule, it became, if you're not burning a subbituminous coal, which has inherently very low sulfur, so that's a number of them do, and could meet the MATS rule, you had to have a scrubber. And you had all these plants in Appalachia where under the earlier SO2 rules that drove driven down SO2, there was a trading program and you didn't have to meet it plant by plant. But the MATS rule said every plant must meet this standard. So it was a type of standard actually economists tend not to like. But it wasn't, the reason it happened, I think, was because it was a part of the Clean Air Act that hadn't really been used before with respect to the utility industry. That was kind of the term.
Would you guess that if it weren't for that rule, there would be more coal still in play, even with the natural gas market?
I would say there'd be some, but I think the thing about it is that when utility companies that own a lot of the capacity, or for even that matter, if they're merchant generating companies, when they saw these things starting to come down the pipe, and then they saw the great concerns on CO2, my own view is even if you had had that rule, you probably had most of what happened occur. Most of those requirements. But it was a factor. It did tilt it for some companies. Okay. I mentioned Powder River Basin being very, very important. This is kind of production over the 2002 to 2018 period. 16 mines in the Powder River produce almost half of all US coal. And most all the coal in the Powder River Basin. And one of the things that happened, certainly in the 2008 period, is Powder River Basin production really kind of soared. Well, most of the other production was flattening out, going down. So most of the growth in demand was from Powder River Basin. Again, why? Well, productivity was great, the coal was cheap. And for a time, railroad rates were actually pretty good from the West into the Midwest, et cetera. You actually had a lot of competition, particularly from Union Pacific and Burlington Northern, kind of the big long haul railroad carriers. And then you had the river system, which allowed you to unload coal in different spots along the way and create competition from the barges versus the railroad. So there was a lot of competition that tended to keep rates relatively low. Some of that really changed, particularly in the last 10, 15 years. But you did have this period, if I look at the graph, I think it's in maybe in the next slide, you see more of a historical look. But, Powder River was, when I started working, it was only 100 million tons of production. Look at it here. It's 500 million tons of production. Really grew. Yeah.
How many mines are there in the US?
Well, there are a lot in East, in Appalachia. Appalachian mines, you remember that visual I showed in the movie? It shows all these slope mines and sort of deep mines, et cetera. I mean, literally, you go to West Virginia and there'll be lots of coal mines. Typically, they go into hillsides. Sometimes they're down in the valleys. There's just a lot of coal there. But it's not easy to create large producing mines. So I'm guessing they're probably in the hundreds of mines in all of Appalachia, rather than really just a handful of Powder River. Yeah.
I just looked it up and the total amount of active mines in the US, there's 1,134.
Yeah. That's why I said in the hundreds, literally probably in Appalachia. Oh, the internet, it makes life easy. So anyway, you see these trends, and again, the Powder River also fell off as coal production was falling, but the ones that really got hit, as you can see in that previous graph with the employment, is a lot of these Appalachian regions. The interior, which is the Illinois Basin, kind of didn't change that much. Just kind of stayed about the same over this period. But look at central and southern Appalachia, which is where all the low sulfur coal was used here to meet the Clean Air Act. Now all of a sudden, you got a different rule, can't use it. Plus the fact that a lot of the older units were located in an area like West Virginia, Ohio, Tennessee, Indiana, et cetera. And all of a sudden, demand from those went way down. So a big change in that particular region. So only if you go back to that previous slide, I think it's at 16 mines. 16 mines produce 43%. And that's pretty much all of Powder River. What's further amazing is you have mines like North Antelope Rochelle mine, it's a Peabody mine, which is 120 million tons of coal. That's per year. These are enormous mines. I had an experience in the 1980s. I was working for a coal company on price forecasting. I was just going through and giving them my company's take on what was going to happen to Central Appalachian coal prices. They were a Central Appalachian producer. And they had a surface mine in West Virginia. It was like kind of in right near the West Virginia Kentucky border. But it was very remote. There was it wasn't easy to get there by car. So I had my first helicopter ride where we went with their management. And they said, well, how would you like to see the mine? I said, yeah, that'd be great. So he took us in a helicopter, and I'll never forget, I guess the pilot loves to do this kind of stuff. We came in and he said, I'm going to swoop down and make this sharp turn through the mine. And you could see all the operations of the mine. And you also were trying not to have vertigo or whatever from the turn. But it really is that these operations are pretty incredible. Now, this was in the 80s and this was in West Virginia. So it isn't even nearly the size of some of these. I mean, this is probably more of a run-of-the-mill 10 million a ton a year mine as opposed to a 120 million ton. So I can only imagine what the helicopter ride would have been like going into that mine. So it's hard to really imagine the scale of these operations. The best way of is to see them. But as I said, these are the elephants and the remaining elephants, if you will, particularly these big mines in Powder Basin, because they are so efficient. Okay, and this is chart, and I think this is 2011. So this is a little bit dated as far as where the production goes. But this gives you some idea of my point about kind of the geographical scope of this 326 million tons. That was as of 2011. It's obviously close to the peak number. And you can see that most of it actually doesn't go locally to Wyoming or Colorado, which is too far away. Only 20 million tons of the 326 million tons, right? A lot of it goes down to the Midwest. See, it doesn't show here. Well, here, Illinois, Indiana, Michigan, Wisconsin. That's almost 100 million tons of the production goes to those 4 states. And you get some scope all the way down to the south. Part of the reason it goes that far is as you get in the south, your natural production, this area down here, it's almost as expensive to ship the Central Appalachian coal from West Virginia down to Georgia or Florida as it is to ship the Powder River coal. Yeah.
So that pie chart that you showed earlier, does it have any variance from eastern to western coal, like less carbon in western coal?
Yeah, the western coals tend to be powder basin are what's called subbituminous coals. If you look on that chart from the first part of the lecture, subbituminous coals run 17 million BTUs a ton. And bituminous coals, which are mostly the ones in the east, run around 24. So it has less energy. So that means less carbon as well. Right. Powder river coal has more moisture, believe it or not. And so there's some issues with higher moisture coals, shipping them, using drying those coals. But so that's a disadvantage of the coal is more subbituminous. And it makes it harder for some of the eastern coals, like I said before, eastern plants to burn that coal.
So it wouldn't necessarily be like greener to use western coal because you just have to burn more of it.
It is, I guess it's greener in the sense that it, fitting the definition. It's lower sulfur, but that's the biggest difference. So most powder basin coal, as I mentioned before, could actually, without a scrubber, meet the max standards. That's probably its green feature. On the other hand, you got to burn more of that coal, probably the carbon dioxide rates are about 10% higher than for continuous coal, or 5 to 10% higher. Okay. So it's not that sense. It's not free. Yeah.
Repeat again why it's more expensive to ship West Virginia coal to the south than Powder River coal?
Some of it has to do with the fact of the rail rates and how rail companies where they rail to. It's not necessarily more expensive. Let's put it this way: it's not significantly different than shipping a longer distance, right? Rates are usually in a per ton mile basis, but the rates per ton mile from heading down here to, let's say, Georgia by a rail line would be higher than the rates coming all the way from Powder Basin. The other thing is you have the river system, and a lot of these shipments from Powder Basin don't just travel straight by rail. In fact, most of them go to either Ohio River or the Mississippi River, and several other rivers, but those are the big two, obviously. And then they move down that river, sometimes right to the power plant, which is right on one of the rivers. A lot of power plants on the Ohio River.
Does Missouri have barges?
Is what?
Missouri have barges?
Yeah, I think so. I think for a portion of it, I don't know if the whole river has it. Not the part I think Lewis and Clark were on.
Well, not back in the day.
The barges don't do well on rapids. It's like say what else here? Well, you can kind of see where the Powder River Basin is. What's interesting is despite all that production, it's really concentrated in an area of kind of northern Wyoming up to Montana, and more on the eastern side of Wyoming, sort of east of Billings. This coal strip was an old power plant. I think that's been now retired, but anyway, that was a location. But then we showed some of the mines, Black Thunder Mine and Becker Mine. So it's not like it covers the whole state or anything. It's just a portion of the state where the reserves are very, very good. Yeah.
So do you think the future of coal, part of it is less production, like even less production of Appalachian coal made up more by like this Powder River Basin? Like, is the trend going to continue? Like,
I think, well, and we'll get to this, and I probably need to move to that, keep having a bet with Brent when I'll finish my lecture sometime or not. I gotta win that bet, but at any rate, I think your question is a really good one. The big driver, I think, in the future of the coal is that we're going to continue to see plants retire. And that's just going to drive overall coal use down, including Powder River Basin, which has been falling in the last decade, really. Its market share is about the same as it was 10 years ago, but overall production is dropping. So yeah, I think it Powder River Basin has that advantage of very good productivity, low coal prices at the mine. I don't want to undersell the fact that it's even the same OT. Some of this coal goes down here, and that has to do with rail rates and stuff. It's still pretty expensive to move coal that far, right? So that kind of puts a damper, even though like mine mouth prices for Powder River coal might be $10 a ton, which is cheap when you compare it to mine mouth prices for Appalachian coal, which is more like $30 a ton. Don't forget, at $10 a ton gets divided by fewer BTUs, and you think about equivalent prices, right? So that's really more expensive than $10 a ton in a sense. And then you've got rail rates and other things that start to kind of equilibrate those two. So they are competing fairly closely. Okay, I wanted to take a quick look, and this, we'll come back to this much more when we start talking about CO2 in the second half of the course, but just to give you some sense of coal production worldwide. It used to be, if I showed this graph in 1970 or 1980, that the US was the big behemoth of producing coal and using coal. I mean, we were like far more coal production, coal consumption than any other country. Now look at it. Unbelievable how much it has changed. And obviously, particularly the one that is just eye-popping on this chart is China, right? China, although it has started a reduction in coal production and coal consumption, let's focus on consumption for a second. China is still producing on the order of, or consuming on the order of 5 billion tons of coal, kind of shrunk to maybe 3 to 4 billion tons of coal in the past couple of years as it's been trying to move away from coal. But the United States, they mentioned, is only 500, 600 million tons of consumption rather than 5 billion. Yeah.
So China and India are like the huge consumers. Do they have like the same air quality regulations that
No.
we do?
No. One of the charts that I'll show you, and actually, I think this is one of those videos you get out of the class talking about it, on the air pollution lecture, shows a picture in the front of an area, one of the cities, with some of the coal production around there, and you can tell just by looking at it that it's not the same as the US. And in fact, the air quality numbers are about taking the worst areas in the US, which interestingly enough, have historically been in California. And it's because of, kind of the ozone pollution levels, particularly in the summer months. That those 10 cities, 10 metropolitan areas in California, and a couple others out west, are an order of magnitude less than the pollution in the 10 top cities in China. Now that's changed some. That's an older chart, overstated. And China's done a few things because even they certainly have recognized that, that's at a level where there really isn't a lot of debate whether the air is unhealthy or not. It's very unhealthy. And so they realize that's not too good for their people not to reduce that level. Some of it's come from reductions in coal. They've actually installed some scrubbers, but it's nowhere near the US still. But I wanted you to get a picture of this just to show that when we get into climate change and we talk about the challenges of getting the world's emissions down, this is where you're starting from. So it's some big numbers, both on coal and also on CO2 from Asia in particular, but also the OECD, the non-OECD countries really are the big drivers. Okay. All right, and let's take a quick look here at where coal production is projected to go. Don't ask me why EIA, this is EIA's chart, decided to call this 2020, but now it's 2020 here. And just note that they got it right on this graph and that graph, but didn't get it right here. So it makes you think, gee, in 2020, at 1.1 million tons of coal production, a billion tons of coal production, down right around here. Actually right there. In 2020. And one of the things they project is the bounce back, right? And we're seeing that. Makes sense, right? But then they're projecting, and they've got several cases. Wouldn't focus too much on what these cases mean, except that a big uncertainty is, all right, what are natural gas prices going to be for the next 20 years, right? Natural gas prices are going really high right now, but let's suppose in the long term they stay at sort of that $3 range that we got used to over the past few years, $2 to $3. That would imply even more back out than their reference case, more reduction in coal. On the other hand, if there's a low oil and gas supply case, which really means higher natural gas prices during the town, coal production overall staying flatter. One thing I keep saying about the EIA cases, and you'll see it in a second, is when I look at it from sort of the bottom up, as opposed to the top down, and I say, what are different utilities doing? You know, what's an AEP doing? What's a Southern company doing? What are some of these major companies who own a lot of the coal plants? Historically, what you see is they're all getting out of coal. Now, that doesn't mean it's going to happen tomorrow or by 2030, but it will happen over this time period. This chart implies it kind of keeps dropping, but pretty slowly. And I don't see that. I think it's going to be much more pronounced. And then, of course, you have to add to the fact of, okay, what's the policy going to be? Are there going to be policies that put a price on carbon, for example? Clearly accelerate that even more. So some open questions about that, but I wanted you to get a sense of what EIA is projecting. Pretty clearly, it's a non-policy case. They don't have a requirement that CO2 hit a level, certainly no carbon neutral requirement by 2050 or even 2040, nothing like that. All right, and then this is kind of giving you that sense of what we've been talking about all along, just in sort of the raw numbers, that natural gas is in 2020 about a 40% share of all generation. Renewables are now 21%. Now, by the way, that counts hydro, the way they do it in this chart. Nuclear kind of in that 19-20% range for a number of years. And then, of course, coal is taking the brunt of the loss of market share from natural gas, and it's gone from literally having more of the overall share of electric generation to considerably less. And in fact, less than right now at the point where it's just not equal to nuclear, which is been a long time since that happened. So probably in, I would say, sometime in the late 1970s before 3 Mile Island might have been close.
So if you're saying that coal's gonna drop even more than the EIA is projecting, are you saying that it's gonna be less consumption?
I just don't
more
see.
renewables or more natural gas?
Let me put it this way. I don't see that a whole bunch of power plants that are coal-fired, 90% of them built before 1990. They're going to be 60 years old. And the rules are such that it's pretty hard between that and if natural gas stays at a reasonable price, if we don't run out of natural gas, I don't think we will. And if we have continuing pressure on the environmental side, even if we don't have a policy, but we have pressure to reduce, I don't see a lot of these guys. I mean, Nick Akins has told me Don't report it to a newspaper, please. That's true, I'm being recorded.
Nick Akins is the CEO.
Let's put it this way, I have heard indirectly. Be very careful here.
Market source, not disclose market source.
I think he and a lot of the other CEOs of companies look at this and say, hey, we're an electric company. We don't want to be known as a coal-fired company, because that's not what we do. We try and produce electricity, but we mostly try and distribute it, transmit it, go to the retail markets, make the grid more reliable, safer, all these things. That's a lot of our mission. Our mission isn't to burn coal or gas or nuclear or use so many renewables. That's not our mission. And coal has become understandably a big political focus, right? And I think, CEOs, and it's not just Nick Akins, look at this and say, why do I want to keep these plants running when they're old? So it's just a different world now than it was even 10 years ago, certainly 20 years ago, in terms of attitudes about it. And this 11% is again off a bigger number, a bigger overall generation, right? This is a percentage chart. And what it implies is that there isn't a lot more retirements of coal that are happening. And I know for a fact that AP is planning, and they've even said it in their, there's no news, if you look at their actual carbon reduction plan, pretty clear they plan by 2030 and then further by 2040 of retiring a lot of plants when they get beyond 50 years of age. So that's what I think. But
Well, that is interesting. If you think of a net zero by 2050, if that's the Paris Agreement, we'll talk about this later. This is not net zero.
yeah, it's not this. Yeah, even
11%, 36%.
yeah, but I mean, again, 11% of demand, a generation that is 30 years higher. If the generation grows by 2% a year, it's still, yeah, it's declining in terms of absolute amount, but it's not declining by 50% in absolute. That's what I meant. And or 100%. So anyway, I just think EIA is not really focused on that in particular. I think also we have to be really careful when we sort of look out to 30 years from now, because I've spent a lot of my working career doing forecasting. And the one thing I learned about forecasting was the best thing you could do with forecasting was to explain to people what the sensitivity of the forecast was, what would drive it one way or the other, what they need to look out for, what would happen with natural gas prices being lower or higher, et cetera, those types of things. The worst thing you could do with forecasting is to tell them, here's the answer, because inevitably you are wrong. I think that's something that it's more important to really understand the whys than to understand some number. Now, having said that, I made a living on producing the numbers because, Congress would have a bill on the Clean Air Act, and I was the guy who's doing the SO2 NOx assessments of Clean Air Act, doing all the modeling for EPA and a number of other parties, other the administration at the time. And, they wanted to know what the number was. And we would caveat the hell out of our results. We always say, okay, this is a single projection. This is kind of a base case, but you really should look at the high and the low case, more of a band of uncertainty, et cetera. Oh, it's an interesting field, at least. And here's the point I was making about coal-fired power plants. You can see the bulk of capacity was built in the 70s. Some in the 80s, and by the time you got to the 90s, you had a little bit of a surge in some coal plants being built around 2010. Part of that was that gas prices were actually pretty high then. And people thought, oh my God, we're running out of gas. You know, that was the theme. And so we needed to build some coal plants. But as you can see, that's still pretty small in comparison to all this capacity built since the early 50s. And well, most of those are built before 1990. They're mostly more than, you know, kind of an average, more than 40 years old already. We started doing assessments in 1980. The assumption that some of the companies we work for, EPA, others work for, typically was plants only going to last 40 or 45 years. Then it reached a point where people said, well, maybe that's not so true, because people can, you know, used to be the old your grandfather's axe adage, right? Grandfather has an axe, messes up the handle, has to replace part of the handle, and the blade needs to be resharpened, maybe needs to be replaced. Eventually, you got brand new axe, really. So the idea was, well, a power plant could be 40 years old, but yeah, you could replace this, replace that, et cetera. Some regulatory reasons and environmental reasons, you couldn't necessarily do that. That would take too much time to explain those. But the point is that there was a period where people thought, oh yeah, they really will last a long time. But then what started to happen was, with the gas technology getting as cheap as it was and as efficient as it was, and it's still getting more efficient, by the way, coal was really having a hard time competing. And then you had environmental requirements, et cetera. So all of a sudden, the paradigm has shifted back to, hey, it starts getting older, gets more expensive to run. Heat rate actually doesn't improve, it gets worse. All those things happen. Really going to push you to a lot of retirements. And this suggests that we're going to see even more retirements in the next 20 years in particular. And here's real and projected. This is through 2020. You can see that EIA has projected a fair number of retirements continuing over to 2025 of coal plants. And where the black is coal. By the way, I hope you noticed what I wore today in honor of coal. As dark as I could, right? And if I give the renewable lecture, I will come in with green, everything. Yeah, I know you will. But anyway, you see all these coal plants that are retiring, 30 gigawatts by 2025, 10 gigawatts, 2024, 20. That's a lot of capacity. These aren't really projections by EIA. These are actual announcements. These are companies that that plant's retiring this year. Now it could change, but it's pretty unlikely to change. So you're seeing a lot of retirements. Now notice right around 2025, that's reduced a lot, not as nearly as many retirements. You say, why is that? Well, because EIA goes from taking the announcements to, okay, now we're going to run our models and see how much have retired. And typically models don't like to retire capacity. And there's a lot of reasons for that. But the short answer is they're understating these retirements, in my opinion. You're going to see more and more here. I know for a fact that at least in their 20 and AEP is in there, you need to be retired capacity also this year. But you do see it's pretty stark. Notice how many gas plants do you see retiring there? The answer is none, right? What you see also retiring is kind of interesting. We don't have a lecture on nuclear, but if you take my sustainable energy class, in the winter, we'll talk about nuclear. And one of the big challenges for nuclear is they're reaching the end of their operating license life. And so as a result, you were seeing retirements being projected, and actually some have actually occurred, and occurring this year. And of course, that's the other big category of retirements. Unfortunately, that doesn't have positive effect on CO2. It's the opposite, right? That's one of the big issues. Nuclear's got a lot of baggage for a lot of reasons. On the other hand, one of the few baseload technologies they got that has zero carbon. So anyway, so that's the trend. And of course, all the additions, what are they? They're all wind, solar, and natural gas. And that says oil and natural gas. I would guarantee that there's probably less than 1% of that. All those additions are oil fired. Almost 99% plus natural gas. Yeah. Yes.
So right before 2025, why is the capacity of solar so much more than wind? That it seems like it just drops off with the wind addition.
Oh, you mean this area here?
Yeah, like right before 2025, it's a lot of wind and then it just drops off. And it's like,
Yeah, again, this is a little bit of their modeling. So again, they take what manufacturers are saying, or merchant generators are saying they're building. And they're in sort of a pipeline and not being built. So I trust this next 4 years is being pretty close to where it will be. After that, they were their magic model. It's like, solar is going to be cheaper at that point, so everyone's going to tilt over to more solar. It's a little simplistic, right? It's probably still going to be a mix. Although, solar share will be higher than it has been historically. That's a very good question. And again, we'll get to that when we talk about renewables in, I don't know, a couple
I'm
weeks.
sorry, the closed captioning is really funny to watch.
What's that?
This closed captioning is actually really funny to watch. What you just said there, there's no relationship. Is it like that all the time?
Yeah.
All right, that's really.
Pretty much.
Because Harry Potter was on there too,
All right, well, and this is not to, since we're getting short on time, and I want to get to the last. So this is, yeah, right. Well, so this is just some of the charts on coal-fired generation, and they do show that, there's high oil and gas supply, meaning low natural gas prices. Then coal will go down even more, as you can see on this chart. But again, the overall direction, even with EIA, I think being a little more conservative about how many retirements there are, is clearly continuing down for coal. And then this is sort of interesting. This is a chart that shows over the last 7 years what's happened with the dispatch between gas and coal. And if we ran this chart all the way back over here, coal would always be ahead of gas, just because the gas prices were relatively higher than the coal prices at that point. But then got real close, and you notice the blue here, the gas, the jabbers out of coal. It's getting dispatched ahead of coal. And of course, the shape of that curve is the summer months being the most important time for power generation. That's where you have the air conditioning load, obviously. And you can see it's significantly higher in those periods for gas and for coal, but particularly for gas. Summer months. All right, so let me finish up with this. The last couple of slides in the last 2 minutes, 3 minutes. This is a variable cost calculation. I'm not going to go through all of this. You have this on the slide. You can take a look at the PowerPoint. But it's really showing a comparison of a coal plant and a gas combined cycle plant. And it's saying if you're in a region and someone is dispatching these plants, remember, if you're the operator, you're going to put in your bid price at your variable costs. right? Economically, that makes the most sense to do. Because you don't want to run, if it's less than a variable cost, you lose money. And hopefully you bid the variable cost and the clearing price ends up being higher, and then you make some money at that out. So typically it's for a variable cost, it's the fuel, that's the biggest part. There's also the variable operating and maintenance cost. And this is going through the machinations, much like we did with the cost of electricity. So I'm not going to belabor it here, but you can see and go through and check it, understand it. I think it's an important concept to understand how plants are dispatched and how that works in the marketplace. And again, coal and gas get dispatched. A little more complicated than being able to turn it on and start running it in an hour. Some coal plants actually have to be kept at a low capacity at night and then are ramped up to their maximum load. So dispatch is a little more complicated. Gas is typically faster. And of course, renewables don't dispatch, right? Renewables are there. If the wind's blowing, you have renewable power, wind power. If it's not blowing, you don't. So kind of a summary is a question that I think have been asked is, will we have any coal? Oops, oh, that was not good. Worst thing is having me manually do things. So some coal plants are going to be around. I don't want to overstate that every coal plant is going to be going, unless you have regulations that are basically mandating or requiring sort of zero carbon in the sector or close to zero carbon. Coal has got some value as a baseload technology. You don't have the variability or volatility in pricing that you do with natural gas, which is a good thing, particularly if you're one of those poor people in Texas. Winter, that strange winter storm, and load went crazy, and natural gas had problems. Coal, more coal would have been nice. And keeping some of the newer coal plants, particularly those ones that are built post 2000, I don't see those retiring for a long time. Only a few of those, but even some built in the 90s, they're probably in their late 80s. Those probably might stay around all the way to 2050. And part of this is the portfolio notion, right? Not having all your eggs in one basket, not being all natural gas, not being all renewable, not being certainly have some coal, have some nuclear. There's a lot of risk analysis that suggests that's the right way to run your system, subject, of course, to whatever environmental requirements you have. And you've got higher reliability benefits. Texas example. One thing though, you got to watch out for is the worldwide coal-fired generation is still growing. China's starting to fall off. Countries like India and other parts of Asia, even Africa, are increasing. So that's a big challenge as far as CO2 goes. Questions? Am I finishing time? 1 minute. Woo.
So homework due tonight, right? Let's let John have some more questions on that. Be here for a couple minutes or maybe send an email.
I pulled it out and did exit because I hate the whole eject thing. And so hopefully I didn't screw the computer up.
Oh, no. Just fine, I'm sure.